Hello, today we are going to talk about checking the choices for ACT prep. This is an important guessing strategy, and the reason I call it a guessing strategy is of course because you're not going to use this strategy unless you're not really sure about the answer. If you know how to do the math, then do the math. You don't need a guessing strategy. But every once in a while you come across a problem and you're looking at that problem and you're just really not sure what to do, or you think you've learned it before but you can't remember really. So this is the time when you're going to use these guessing strategies, and checking the choices is a great one. So I'm going to demonstrate how to use check the choices. I'm going to go through a few problems just to kind of show you when you would use it on what kinds of problems, and hopefully this will help you just a little bit. So let's go to the first problem. It says right here that this month Cami sold 70 figurines in 2 sizes. The large figurines sold for $12 each. Now I am going to use one of my techniques for the ACT that I really want you to strongly consider, and that is underlining important information. She's got 70 figurines in 2 sizes. That's important. Large figurines sold for $12 each, and the small figurines sold for $8 each. It's really important on the ACT that you don't want to try to read a question twice. You want to be able to get all the information out of the problem the first time through the problem. It really wastes a lot of your precious time when you've got 60 questions you've got to get done in 60 minutes, and you don't want to have to waste that. So I strongly suggest you underline the important things as you go through. So she's got 70 figurines in 2 sizes. She's got some large at $12 a piece and small ones at $8 a piece. It does say the amount of money that he received from the sale of the large figurines was equal to the amount of money he received from the sale of the small figurines. So the money figure is the same for both. How many large figurines did Cami sell this month? So let's say she sold 35. We always choose the middle value when we start these. If she sold 35 large figurines at $12 each, and we multiply that out, 35 times 12, you can see that we get $420 in money charged for the large figurines. So if I look at the small ones, and I have to assume that we sold $420 worth of small ones also, 420 divided by $8 a piece, that's going to mean that I sold 52.5, which is ridiculous. I can't sell half of one. 52.5 small figurines. Now you can see between the two of those that does not add up to 70. So that was clearly not going to work, and it gave me way too many figurines. So since that number gave me too many small ones, then why don't we go down and try a smaller number? Okay, let's go down and try a smaller number. So let's say we sold 28 large figurines. So I go to 28 times 12, and I sold $336 in large figurines. If I take that number and divide by the cost of the small ones, divided by $8, that means I sold 42 small figurines. 42 plus 28 is 70, the number that I'm trying to get at the top. So I know that I got it right. I know that it's got to be B. Now, if that number had not worked out, if I had still had too many, then I could have immediately chose A, and I wouldn't even have had to check it, because I knew that C didn't work. I knew that because it was too much. B didn't work for whatever reason, so it would have had to have been A. But since B did work, I didn't have to do that. So the answer was B. So I hope you can understand what I'm trying to say there by choosing the middle number and then deciding whether to go up with that number or down with that number really helps you eliminate some of the choices, and one of our favorite techniques as far as the ACT goes. So let's look at another example. This is a scientific notation problem, and man, I remember learning scientific notation in one of my classes, but man, I just cannot remember how to do it. But I can add these two numbers together pretty well. That seems to be a fairly doable question. All the zeros are going to clearly make 6 zeros at the end of my number. So all I have to do is add 700 plus 670. So 700, I'll do a little scratch paper here, plus 670 gives me 1,370. Plop that number right in there. So those two numbers added together is 1,370,000,000. Now all I got to do is figure out which one of these choices is 1,370,000,000, and it's really kind of hard to tell from these choices. Now I can eliminate this one because that's not scientific notation. Scientific notation starts with a number between 1 and 10. Clearly it doesn't match the rest. You can look for those oddball answers every once in a while that are just off the charts, doesn't match anything else, ridiculous. I'm not even really sure why they put those in there, but oftentimes those are going to clearly be a wrong answer. Now I'm going to choose the middle one. You can't see it there because I covered up the 8, but it's 1.37 times 10 to the 8th. And I'm literally going to put that in my calculator. And I get a number, and I put this comma in the wrong spot. I get 137 million. That's not enough. I need something higher. I need a bigger number. So maybe I'll try this one. I'm hoping this is the answer, because if this is not the answer, then I'm in trouble because I already eliminated this guy. So I type in my calculator 1.37 times 10 to the 9th power, and I get this answer. I'm going to throw my commas in. And what did I do wrong? 3, 6, 9. Oh, I only needed 7 zeros. I'm sorry. I only needed 7 zeros there. So we'll put a comma here. Let me just rewrite that for you. I apologize. 137. I need 7 zeros. There we go. Now we got it. I was wondering why that answer didn't come out like it was supposed to. Those two were supposed to match. Well, anyway, I really probably didn't even need to check that answer. Once I decided that this was not it, but it was too small, and I knew this wasn't it because that's not scientific notation, then I could have just circled that answer and gone on with the problem. I didn't even really need to check it. So trust yourself when you're using this method. This method is designed to eliminate some of those choices. Let's try another one. All right, a computer chip, 0.32 centimeters, 32 hundredths of a centimeter thick, is made up of layers of silicon. If the top and bottom layers are each 0.03 centimeters thick and the inner layers are each 0.02 centimeters thick, how many inner layers are there? All right, so this is the entire width of that piece, that chip. So again, not sure how to do it, so I picked the middle number. Let's assume there are 16 middle layers. Well, 16 times 0.02 gives me exactly 0.32 centimeters. That's a problem because that doesn't give me enough for the top and the bottom. So that top layer and the bottom layer. Because I have a top layer and a bottom layer I need to squeeze in there somehow too, and I've already used up my entire 0.32 centimeters. That was a little too much. So let's go ahead and try 15. If I do 15 of these, well, now I get 0.30 centimeters. Now if that's the inner layer, now remember I have a top and bottom that's 0.3. I have a top and bottom that's each 0.03 also that I'm going to have to add on to this. Again, I still don't have enough to add 0.03 2 times. Okay, that's going to be 0.36. I'm shooting for 0.32. So my answer is definitely going to be 13. I don't even need to check it, because these two didn't work. I was still getting too much. But I'll check it just so that I can say I did. I'm not on a time constraint here. I'm just doodling. So I've got 13 inner layers. 13 times 0.02 gives me 0.26. I have a top and a bottom. They're each 0.03. 9, 10, 11, 12. Carry my 3, and it's 0.32. So what I'm saying is such a great technique. Check the middle one. If it's too much, go down. If that's still too much, don't check the last one. Just circle it and move on. Alright, I think that was my last example, so I hope that helps you out a little bit and gives you some confidence to try some of these problems when you're just not really sure of the answer. Hope you have a great day, and we'll catch you soon.